The following video will introduce you to VisualDOC. Today, I will explain some of the basic features of this multidisciplinary design optimization software. In this video, I will show you an example of how to create a basic VisualDOC model, how to run the example, and how to monitor or post-process the design results. I hope this example can help you to get familiar with VisualDOC graphical interface. But before we start the example, let me briefly discuss what VisualDOC is. This software enables a user to model virtually any kind of design process and to couple design modules such as optimization, design of experiments, response surface, or probabilistic modeling with any analysis program. VisualDOC supports interactive and batch mode execution. It can integrate with Excel, MATLAB, and various CAE software. Examples of tightly integrated software include Genesis and ANSYS. To get started, let's open VisualDOC. The first thing that you might notice is the main VisualDOC window, which is divided into three parts. The central part in which you can see the graphical representation of a VisualDOC model. On the left side, you will be able to see the tree view of your VisualDOC model after creating the model. At the bottom of the main window, there is the message area, which is used to show information such as warnings or errors. I will explain each of these parts in detail later in this video. For now, I would like to mention just few things about some items in the main window. The model tree provides an easy way to access all the components in the model. Next to the tree view, there is toolbar from which you can select various components for the workflow. It is called as component palette. At the bottom, there is a status bar which displays information on the task which is currently open. It also shows the verbosity level, the operating mode, and the amount of memory in use. Let's start with a simple example to demonstrate the steps required to solve a basic optimization problem. Here, objective function is to minimize x square plus y square upon 10 minus cos x into cos y. It is subjected to constraint x square plus y square greater than or equal to 1.5. Constraints on design variables. For x, lower bound is -2 and upper bound is 2. For y, lower bound is -2 and upper bound is 4. This is a very simple example for demonstration. VisualDOC is capable of solving extremely complex problems. Now click on File from main menu bar. Click on New Project. Select the folder where you want to save the project. Enter the name as equation. Click on New Project Database. These steps make VisualDOC create a new database. Next step is to create workflow. The workflow always starts at start block and can end at one of multiple stop blocks. You can have multiple stop blocks. If you have conditional branching, then execution will stop when it encounters a stop block. Now I'm going to add an optimization component. Click on the optimization component from component palette and then click on the canvas to add component at that location. Next, I'm going to add equation component. The reason I'm adding equation component is that the analysis is a simple set of equations. The equation component is ideally suited for the problem. Now click on the equation component from component palette and then click inside the optimization component on the canvas. I'm placing the equation component inside the optimization component as the equation component will be used to define analysis needed for optimization component. Now let's add a stop block. The components in the main window has to be connected. To make the connections, there are two possible ways. First one is click on the flowchart components from the model tree panel on the left and then click on Auto Connect All Models icon. It is very important to note that Auto Connect will connect the components based on their positions in the model tree on the left. Make sure that order of the components is correct in the model tree. Second way is to click on Switch to Connection Mode icon. This will allow you to make connections between components manually. You can arrange all the added components manually. Click and hold the component and drag it to desired location. Or click on Automatically Rearrange All Models icon and select Yes. The next step is to set up the equation component. Now go to Component Editor tab. Select Equation Component from Model Tree panel. Now enter the data for the problem in the middle panel. X and Y are the input variables, and F and G are functions of X and Y which are defined as output. Select Output from drop-down list in front of data F and G in Input-Output column. The initial value for input variables is set to 1. VisualDOC supports 3 types of data type: scalar, vector, and raw array. For this problem, we will use the scalar type. Now I will type the equations in the panel on the right side. It is very important to test the typed equation to ensure that the typed equations are correct. Push the test button to validate the typed equations. After a successful execution, you can see the output values in the middle panel. Now we will create the flow of data transfer. This is done to specify information transfer between different components. Only the data that have the same data type can be linked. There are in total 7 types of links which VisualDOC can support. For this problem, we will be using scalar to scalar since, as mentioned earlier, all the data types used in this problem are scalar. Now go to Data Linker tab. Select Optimization in Model Tree panel. Select Optimization in middle panel. Make sure that Auto-Link checkbox is selected. Click on Automatically Add Data to Selected Model icon. This will create the data needed for optimization component and add the corresponding links for the data transfer between the optimization and the analysis components. Next task is to set up the optimization component. Go to Component Editor tab. Click on Optimization component in the Model Tree panel. As soon as the data links are added, VisualDOC will automatically transfer the design variables and the responses to the optimization component. For X and Y, click on the checkbox under Variable column. For data F, click on the checkbox in the Objective column. As this response is the objective, select Minimize option from the drop-down list in the Goal column. For data G, click on the checkbox in Constraint column. Enter the lower bound as 1.5. I will be using the modified method of feasible directions, which is default gradient-based optimization method in VisualDOC. Now we will add the simulation monitors which we can use later to monitor the progress of the process. Monitors can be used both during the simulation and after the simulation. For this problem, I will create 2 monitors to view the best objective value and the worst constraint violation. Now go to Simulation Monitors tab. From the toolbar on the right, select Add Optimization History Monitor icon. Add another Optimization History Monitor. Now click on Expand the Complete Hierarchy icon below the Flowchart Components panel as well as below the List of Monitors panel. Drag the best objective under Simulation parameter and drop it on the x1 axis of the first monitor. Similarly, for the second optimization history monitor, drag the worst constraint violation and drop it on the x1 axis of the second monitor. By default, all monitors are in disable state and need to be enabled to activate them. Thus, click on Enable All Monitors icon. Next, click on the Validate icon on the toolbar below the main menu to validate the model before running it. Under the Standard Message tab in the message area, you should get the message the complete model is valid. Now, click on the Run icon to execute optimization process. Click on the View Monitors tab in the message area. In this area, you can see the defined monitors. For both optimization history monitors, x-axis represents the number of iterations. As you can see from the graph, for this problem, the total number of iterations are 4. First optimization history monitor displays best objective value for each iteration. Second optimization history monitor displays worst constraint violation value for each iteration. Once the optimization task is completed, to view the optimum results, select Component Editor tab. Select Optimization component from Model Tree panel. The table displayed in the middle panel has the optimum values in the optimum column. The optimum value for function f is -0.27. To see the summary of the optimization task, click on the Post-Processing tab. Click on the Generate Summary Report icon. You can see all design points and function values at those points by clicking on Show Design Points Table icon. It is interesting to mention that in VisualDOC, key numerical and graphical updates can be observed in real time. Go to Component Editor tab. Select Optimization in Model Tree panel. When the simulation is running, values shown there are dynamically updated. Also, when the simulation is running, the icon shown on the top right corner in the main window keeps animating. Now go to Workflow tab and run the simulation again. You can see the component while it's been executed is been highlighted. The simulation monitors also get updated when the process is underway. This completes the demo. I hope it has helped you to get familiar with VisualDOC. If you would like to learn more, I invite you to check other videos about VisualDOC. For additional information, please visit our website at www.vrand.com or email us at visualdoc.support@vrand.com. Thanks for watching.